Hey guys, Larry C here. Did you hear about the restaurant on the moon? Great food, but no atmosphere. Shout out to you all. Hope you enjoyed the video.
Come on now, dog. Come on, man.
All right, guys, Larry C here with another installment of Build a Stats course with me. What's up, Stat Cats? Let's dive right in. All right, I'm having a hard time deciding where I want this panel of myself in. Let's see if I can shrink it down. Oh, I can. Nice. All right, let me put it down here. Okay. All right, gang. So we're starting a new chapter in this video, chapter 2. And chapter 2, let's see if it's got a main title to it. It does, Exploring Data with Tables and Graphs. All right, so that's not a very exciting title for a chapter, but it is all encompassing of all the material that's in this chapter. The first section, and again, this is from the Triola. If you've been following my other videos, this is from Elementary Statistics, 14th edition by Mario Triola. They don't pay me to say that, but I do want to give, justice where justice is due, and shout out to him. And by the way, this is all fair use. Okay, so I'm doing this for teaching purposes as well as added commentary. All right, shout out to the coach gang for teaching me that. Okay, so section 2.1 is on frequency distributions for organizing and summarizing data. All right, so yeah, I actually struggled with this section a little bit, not because of the material. The material is actually fairly straightforward, but it's not very exciting. And one of the reasons why that is because this is mainly focused on frequency distributions or frequency tables, and there aren't really a whole lot of pictures to it, which I guess is okay. This is a stepping stone to section 2, which is on histograms, which would be graphs that look like these. So I decided to throw a few histograms in here anyway, just to, I guess, jazz it up a little bit. So I'm leading off this section of notes with a question. Have you seen graphs like these before? And I'm pretty confident that my students will say yes to this. And this one's in honor of my wife right here, books read in a month. All right, so number of books read, and then we have the corresponding frequencies. All right, so I'm going to make some commentary about this to introduce this chapter and section. And then I decided to put this one in here too because this is tied into some of the examples that are going to be throughout the rest of this section. So basically bar graphs, that's what histograms are. So quite a few definitions. So that can lead for some boring lecture, but it's got to get done. So graphs like the ones above, which are known as histograms, can be built from what's called a frequency distribution. So this right here allows me to segue into this definition, as well as overall segue into the next section, which is on making these graphs. So I define a frequency distribution here, which is also known as a frequency table. It shows how data are partitioned among several categories or classes by listing categories along with the number, aka frequency, of data values in each of them. All right, so we got a few definitions sort of packed into one here. So I separated out what a frequency is. A frequency for a particular class is the number of original values that fall into that class. So at this point, what I usually find is that it's death by definition here. So I try not to give too many more definitions after this if I can avoid it. So, and that's kind of information overload I find nowadays. I've been teaching for about 22 years, and you kind of want to splice in something that's tangible so that they can start to grow those dendrites and, begin to sort of piece all these things together, all right, for the main concept. And I'm sorry if I'm sounding like word salad. I'm about to get to my point right here. All right. So um, to tie everything in, I included this example, which are screenshots from the textbook. And as you can kind of tell in the frequency table, these values are meant to designate daily commute times in Los Angeles in terms of minutes. And I wanted to include this part along with the data to connect everything. So imagine that all of these are measurements taken from somebody. And of course, we're measuring how long it takes to commute from point A to point B in Los Angeles, although that's not specified, and that's okay. So some data would fall in between 0 and 14 minutes. There's actually no zeros in here, shocking, right? But I'll get to those details in just a little bit. And there are 6 data values that fall in between 0 and 14. There'd be 18 data values that fall between 15 and 29. Okay, so 18 measurements would have values that fall between 15 and 29, and so on and so forth. So it might be a good idea for an example like this to kind of foreshadow some more definitions that are coming later, but also maybe, have them get a little interactive with this. Like, okay, can you guys identify um, how many data values are between 0 and 14 minutes? And so you can instruct them to start by looking left to right with the first row. Okay, so going from left to right, looks like the first value that falls between 0 and 14 is 8. So they can kind of check that off. And then we have a pair of 10s. They can check those two off. And so you can kind of have them verify a couple of these frequency values, which I think is a good instructional strategy, because it kind of primes them for examples where they have to do this from scratch. And I'm going to teach you guys about another strategy that I've been using in my classes. I like to call it the anatomy of a blank. Okay, so this is something that I've used for describing um, objects in math that have different pieces tied into them. So, for example, the anatomy of a parabola. I might include the graph of a parabola and point out like the vertex or the axis of symmetry or where the x-intercepts are at, corresponding points, and so on and so forth. So, and that's something that I like to do, and maybe it's a nod to the medical field or paying homage to my mom who used to study anatomy and physiology while I would be doing homework um, at the dinner table together, and she'd kind of like quiz me on these random body parts, and I'd like, you know, I have no idea what the femur is or anything like that. So anyway, so yeah, I like to do like the anatomy of a blank, and I thought it might be a good opportunity to use that teaching strategy with the anatomy of a frequency table or a frequency distribution. So it says here, let's use the graphic below to learn some important terminologies regarding the different components of a frequency table. Say that 5 times fast. So here I built this using Microsoft Word, and I'll show you again how you could do that. You go to Insert, Table, and there are 2 columns, and I decided just to include a few rows. Of course, frequency tables could be shorter or longer than this. And I grabbed this little square right here to just kind of, adjust the width and height. And to get these words in the center of it, what you can do is you can highlight all of the cells at one time by holding the left um, button down on your mouse. And you go to table layout, and then there should be some icons here. And the one that I use most is this middle one where it says align center. And what that's going to do is it's going to put you at the center of, the cell that you're typing in. So hello. And then you'll notice that the table is a little thick, like the borders. It's a thick time. So what you could do there to adjust that is you could go to table design, and then I use this area where I adjust the thickness of it by maybe selecting 1.5 or 2.25, as my friend Jay would say from Jersey. And then this little if you can see, I'll kind of spin it around. It's kind of like the tip of a paintbrush. What you could do is you kind of hover over the border that you want thick, and you just left click it. Okay, so you can do that with all the borders. I'm sure there's probably a faster way to do this, but this is the one that is kind of like my go-to fail-safe. And then I want to show you where you can get the ellipses, which are these guys right here. So what I did for that is I just went to one of the bottom two cells in that last row, and you go to Insert, Equation, and this is something that I learned from my linear algebra class. So you go to this matrix icon, you click that, and right here where it says dots, you can select the vertical ellipses, and then you can change the size accordingly. Okay. All right, so going back to this, I'm just going to teach them how our classes are normally organized in the first column, and then our frequencies are organized in the second column. And then to follow this up, there's a lot of terminology with this, hence the reason why I do the anatomy stuff. So I want to give them both a visual in addition to the text here. So the smallest numbers that can belong to each of the different classes, those would be lower class limits. So what I plan on doing is maybe writing like A dash B, lowercase, and then just drawing an arrow to A and labeling that as the lower class limit, and then an arrow to B, indicating that that's the upper class limit. And then it says here there's these are the true dividing lines between classes. So what I'm thinking about doing is drawing an arrow. So you can go to Insert Shapes and select the arrow key, and then maybe just drawing an arrow to this line right here, and indicating that that is a class boundary, which is going to be the average of the upper class limit of the previous class and the lower class limit of the next class. So if I do like C through D, then we would have B plus C all over 2 for the class boundary. So I'm still kind of working out the finer details of that, but I'm pretty sure that's what I'm going to roll with, because that's what inspired this idea to begin with. And then values that are in the middle of each class, so those would be class midpoints. And so we're going to be writing all these terminologies down, because I believe that there's something to be said about writing something down yourself and then it being committed to memory. And then of course class width. So we'll have all these terms here related to the frequency table, and then we'll just be drawing arrows and annotating it accordingly to connect the dots, so to speak. So then we get into the real meat of the section, which is constructing a frequency distribution. So these are instructions that I more or less took from the textbook, and I'll go ahead and show you that. It's not too far into the section. Right here. Yeah, so this is on page 47 of the textbook. As you can see, it's quite wordy, and they give some extra information that I don't really think is absolutely necessary to include, but it says the ideal number of classes for a frequency distribution could be, this looks like a change of base formula, 1 plus log base 2 of n. Anyway, so number one says select the number of classes, usually between 5 and 20. So I made sure to include that. Okay, I think that's the main point of item 1. And then item 2 is calculate the class width. So I included this formula, but used W as like a variable. So as you can see here, W, maximum data value minus minimum data value divided by the number of classes. Then item number 3, choose a value for the lower class limit by using either the minimum value or a convenient value below the minimum. So going back up to this frequency table, they used 0 because that's a nice lower limit to use. So even though none of these data points are 0, the number 0 itself, it still kind of gives us a nice boundary in which to fit the data within. You can kind of think number line, if you will. Determine and list the upper class limits, then count the amount of data values that fall into each class and write the frequency down. So that is essentially their step 6. Take each individual data, put a tally mark. So I decided to leave that off, the tally mark. Then add the tally mark. So I kind of spent some time rephrasing this, and this is the best that I could do. Count the amount of data values that fall in each class and write the frequency down. And I think that that's pretty digestible for students. So here's an example where we're going to do everything from scratch. Oh, I forgot to complete this note, so I'll do it live. So data of drive-through service times in seconds at Burger King are given in the table below. Times are for lunch orders, which they define lunch as being from 11 to 2 p.m. Burger King does, at least at the time of this recording. And begin when a vehicle stops at the order window, and end when the vehicle leaves the pickup table. So all of these 20 data points are different time values in which things have been measured, customer orders during this time frame of 11 to 2 p.m. So it says construct a frequency distribution for the data, and then here's the note that I wanted to include in here. If a data value falls on the lower there we go, class boundary, include it in that class. If it falls on the upper class boundary, do not include it in that class. So this is just something that was decided on by convention. And when you work through this example, I believe if you use like 10 classes, this is liable to happen with a couple of data values in the table. So we're going to kind of poke around and decide, what would be a convenient number of classes to use. In the textbook itself, which is where these data values come from, let me go ahead and take you to this problem, which is on page 53. Okay, Burger King lunch service times. So it says refer to data set 36. And it says here, use the drive-through service times of Burger King lunches. Begin with the lower class limit of 70 seconds and use a class with the 40 seconds. So they're actually helping us out in these instructions. They're telling us what to use as the lower class limit of the first class. Then you would add 40 seconds to that to get the lower class limit of the second class. And you would continue doing that until you no longer need any classes, which that's indicative by a bunch of classes with zeros in them. And, trending out that way with a whole bunch of zeros indefinitely. But I wanted to make it a little more challenging because I think it's more real life that way. So I don't give that tip here because I think this is a great opportunity for dialogue and discussion between you and the students. Like why would using 5 classes not be a good thing? In this case, why would using 10 classes perhaps be better? And I'm just kind of making stuff up on the spot at this point in time, but I think you get what I'm trying to achieve with that comment. And of course, I do have the king in there, but I do want to let you know that click on the data set. I went to this website, triolastats.com. Copy that. I'll enter it in. And I want to show you where I got those data values from. So triolastats.com, click on, this is the what the cover of my book looks like, and I went to download data stats or data sets, and I downloaded the Excel version of them. And then let's see, 36 is fast food. This opens up an Excel file. And enable editing. So these are the Burger King lunch times. I'll highlight those for you. And what I did is I selected the first 20. And I only selected 20 of them because there are 50 data values. And I think if you include all 50, although it'd be better in terms of the resolution of a frequency of a histogram, it could take it could take more time than necessary when doing the example that we're currently on. So I selected all 20 of those. It's actually 19. There we go, all 20 right there. And I just inserted them into a table, which I created using this feature in Word. So we're going to create a frequency table for this, and actually, you know what? We don't need that because I totally forgot about this. I actually made that note down here. Note, some values in the data set fall on boundaries for the class intervals. The value is counted in the class interval if it falls on the left boundary, so that's the lower class limit. Put that in class limit, aka left boundary. Give it to them in a couple of ways, never hurts to do that. But don't include it if it falls on the right boundary, so we would put that in the next class. Okay. And then we're getting towards the end here. So relative and cumulative frequency distribution. So you might be aware that there's more to a frequency table that you can do. You can start to include some percentages. And these are really good things to have, especially when you're talking about percentiles. So this is kind of like an introduction to that, although they won't be aware of it at this point in the semester. Um, but it's good to have things in terms of percentages, especially when you're comparing two different data sets that you've created frequency distributions for. If they share, let's say, driving times in Chicago versus the driving times in Los Angeles. So just giving them a couple of formulas to help us calculate those percentages. We have the relative frequency for a class, which is going to be the frequency of that class divided by the sum of all frequencies. And then the percentage for a class, basically this formula times 100%. So we just basically convert this decimal to a percent. So what I am doing after I introduce those formulas is I'm referencing them back to the previous page so that we can add on another column for relative frequency. So somewhere down here we'll have our frequency table, and then I'll make sure that they allocate some room so that we can include a column for the relative frequency. Then we'll return back to this page. It says the sum of percentages in the relative frequency distribution should add up to 100%, but can be slightly more or less depending on rounding. So I'm imagining that there's going to be some rounding that we have to do when we create the relative frequencies for this data set. And although I haven't worked out the full solution to it, there's a slight chance that the percentages add up to 101% or maybe like 99.5%. So I think that's a good teachable moment for something about rounding errors. Rounding, as I like to say, is not an exact science. So after making that point, I'm going to phase into cumulative frequency, which is pretty cool. This is actually where you start to get into percentiles. So it says one way to simplify analysis involving frequency and relative frequency distributions is to incorporate a metric or a measurement known as cumulative frequency. And this is a value that is made up of the sum of the frequencies of the class in question. Um, so as well as all previous classes. So it's kind of in the name cumulative. You can think of accumulative, where you keep adding things up. And at this point, um, we're introducing a lot of different elements of a frequency distribution. So I think it's important to keep things tangible to real life stuff. And one of the things that I was researching led me to the 80/20 rule, which actually has a slight connection to cumulative frequencies. So what I did is I included a hyperlink to a YouTube video on the Pareto principle, which is essentially the 80/20 rule. And time permitting, um, like I could show this video, which I believe is like 2 or 3 minutes long, and just to make it relevant to, um, real life. And it's also a good statistical thing to look at the Pareto principle. So, just to kind of tie things in and make it tangible and something that students can latch on to when they're trying to remember all these different definitions. It's also worth mentioning that you can make frequency tables for categorical data. So it says here, construct columns for the relative and cumulative frequencies for the following table involving causes of fatal plane crashes from 1960 until a recent year. And this is verbiage from our textbook. I think it's kind of funny. So yeah, as you're seeing here, this is categorical data. So, non-numerical data, basically categories. But there are frequencies. So, somebody has counted the amount of times that a fatal plane crash has resulted from pilot error, mechanical errors, and so on and so forth. So I left some space to create two columns, one column for relative frequencies, so percentages, and then cumulative frequencies. So we're going to draw those on ourselves. That way I can teach them how to actually calculate these sorts of things. Okay, last but not least, one of the most important forms of the distribution of all statistics, the normal distribution. So normal distribution is a first encounter. So this is just going to be like getting their feet wet with a normal distribution and its characteristics. So it says here, soon we'll be creating graphs of our frequency distributions, which are histograms. One major benefit of doing this is so that we can visualize, I should say, the nature of the shape and spread of the data over the range of values. So this is a histogram that I created using a software called StatDisk, which is associated with our textbook. And I'll show you how to do that. So what you do is you type in statdisk.com, statdisk.com, and you can click on this tab called Data Sets, and it takes you to Elementary Statistics 14th edition. You can select that option, and I did, it was body data. Yeah, so I selected body data, and I did the histogram for diastolic measurements. So this column. All right. So to get a histogram made, what you could do is you can select the Data Tools tab and click on Explore Data. And then you can select whichever column you want to analyze. So diastolic, evaluate, and boom, it creates the histogram for you, as well as gives you some stats that we're going to be learning about throughout the rest of the semester. And I just screenshotted this. I believe you can download it as a PNG, and you can just right click, copy and paste it into your notes. But that's how I created this. And I'm not going to give too much dialogue behind like what this data is and so on and so forth. I just want to show them the shape of it. Because the hallmark feature of a normal distribution is that when you graph it, it's a bell shape, which shout out to Taco Bell. All right, so I put that in there so that they can, um, link. Let's see, I lost my camera. So I put that in there so that they have a visual to attach this definition to. And I figured I'd kind of play around a little bit today, and let's do this. There we go. All right. So the above graph is said to have a roughly bell shape, which is a hallmark feature of a normal distribution. All right. So one of the most important types of graphs in statistics. So data that have an approximately normal distribution have a frequency distribution with the following features. So frequencies start low, then increase to one or two high frequencies, and then decrease to a low frequency. So we'll write that down. And the distribution is approximately symmetric. That's going to be the word in there. So frequencies come in before the maximum frequency. Your frequency should be a roughly mirror image of those that follow them. And you can kind of link this back to the graph right here. So always good to have the visual whenever possible. That way they can connect the, you know, the text to the written description to a visual description. That's what I'm trying to say. And then to finish the section out, this is a screenshot from the textbook. And the idea here is not to have this graphed out, but to just examine the frequencies. And you can see it starts out very low with a value of 1, then it climbs up to 29, then to 38, and then it starts to drop back down to 16, down to 6, down to 1. So, if we were to look at this from top to bottom, it does have these two characteristics of the normal distribution that I'm going to be discussing with them. All right, and that's a wrap for this section and for this video. Of course, if you have any questions or if you want the notes from me, feel free to leave a comment below. Otherwise, thanks for hanging in there with me, and shout out to you all. Let's keep bossing up. Have a great rest of your day, Stat Cats.